So let's see some examples of that. So the first one is the deworming example that I was talking about. And this was done also in a randomized experiment. That's the one I was talking to you about, where they realized that the more people you knew the more people you knew who took the deworming, the less likely you were to take it. Well, it turned out that was actually a mistake, because being dewormed is extremely helpful. So what they did is, this is the region where they worked, where you have a bunch of schools. This is a map. You can see that the map is, the region is close to the Lake Victoria. One, particularly schistosomiasis, is something that you're much more likely to get if you're walking in the clean water, in the fresh water, particularly when it's not that clean, but when it's not salty. So worms basically climb from the sole of your feet inside. So with these kids go fishing in the lake, or go hang out in the lake, much more likely to get worms. So this region is reinfected by worms. About a quarter of the world children suffer from worms. One thing with worms is that they've never killed anybody, or at least not these worms. There are some worms that gives you very spectacular big legs, and those worms are a little bit more fashionable. But this little kind of hookworm schistosomiasis doesn't kill people. You can't really see that someone has them. So as a result, it's not a disease that anybody is particularly excited about. So I want to make you excited about worms for about at least 15 minutes. You can come back and say, well, these worms, there is something with them. So they went to this. The researcher went to this area, and they separated the schools into 3 groups randomly. Why did they pick the school? Why did they randomize? Why did they decide to randomize at the school level instead of doing it within school? For example, if you remember the bednet experiment, the bednet experiment was done at the individual level. Here they treated all the children in a school, or the children was left as control. Why did they decide to do at the school level? Yep?
So kind of kids' education may affect one another. So if one child in a classroom is dewormed and the other is not, they may be learning better. But because they're learning better, the other child may also be increasing their understanding. If you do it at school level, they can cancel out that effect. So they can compare schools where all children are and schools where all children are not.
Right. So kids' education could affect one another. What else? In what way could they also affect one another?
Isn't there the externality of one person because they're very contagious, you said?
Right. There is the direct deworming externality that Zach and Noah mentioned earlier, which is actually worms as hyper-contagious. So if you compare, when they had done randomized experiment before within school, they were very surprised because saying, we are deworming these children and we see no effect on anything. And the thing is, the control kids were reinfecting the treated kid, and the treated kid were also making the control kid less sick, so the effect was 0. So here they decided, let's go and randomize at the school level. And the first thing they did is that they went into the schools, so they did the schools in 3 groups. They dewormed the group 1 in 98-2003, then dewormed the group 2 in 99-2003, and dewormed the group 3 in 2001-2003. So the group that was at the group 3, children, got on average 2 fewer years of deworming compared to the group 1 and 2. There was a first study they did, which was where they collected data in 2000. And in 2000, they compared children in group 1 and 2 to children in group 3. So children in group 1 and 2 had been treated either 1 or 2 years, and children in group 3 had not been treated yet. And what they found at this time was children, of course, were less likely to have worms if they had been dewormed. Otherwise, there is not much study to talk about. Number 1 is children who had been dewormed are taller. They are less likely to be anemic. And importantly, they are less likely to miss schools. So they found that there was an increase of about 15%, so 1/6 of a year in the participation in school. So what this study that we are doing now does is that it's tracking the children who were in primary school at this time, later when they grow up. So the data we're going to look at is in 2007, 2009. So a kid who was 10 in 1998 is now 20, and is therefore usually doing something, working. And therefore, they can start looking at whether these people are now earning more money. And so it's a big project because these children have gone all over the place. So they have had some difficulty finding them. Some of them, one of them was in London, and they went and interviewed a person in London. Many of them had moved to Nairobi, or had moved to Mombasa, or had moved to Uganda. So what they did is they did a first wave where they tried to track everyone, and they found about 60% of the people. And that's not enough because the 40% you don't find might be the one that have the bigger effect. They might be the one that have moved to London because of the extra education they're getting. So then they decided, let's take a smaller number of kids and track them wherever they are, really find them. And when you do that, they found a quite large number of them, so that altogether in the sample, they have about 85% of tracking rate. In treatment and in control, it's very similarly. So therefore, we can now look at what happened to wages. So this is a distribution, or the empirical distribution of log wages. So what this tells you is roughly, if you take any line here, I can take my thingy. Take any line here. For example, it says log earning of 7. So wages tend to be log normal, so we like to show logs. So in the treatment group, about 10% of people earn a log of 7. And in the control group, that's about 21%, 25%, something like that. So what does this mean, this movement of what happens to the distribution of wage between treatment and control, and what does this mean? How do we read this? You can do it. You've seen a distribution of any distribution before, I know that. So well, just describe what happens to these two curves. You. I was talking to you. Just describe what happens to these two curves. Just tell me physically what happened to these two curves. They moved right? Yeah. Right? That was hard. They moved right. Now, what is hard is saying, well, now that they move right, what does this mean? No. Right. So those two things are exactly true. So what we see is, number one, here is the peak. So this is where, in the control group, we get 45% of people earning about a wage of 8. That's the mode of the distribution. And then the nice thing with wages is they tend to be log normal, which means that the mode is about the median. That means that it also means that 50% of the people in the control group earn less than 8. Whereas here we find that if we want to find 50% of the people earning less than something, it's closer. Sorry, for the control group, it's like 7.5, and the treatment group is 8. So in the control group, 50% of people earn less than 7.5, and in the treatment group, 50% of people earn less than 8. And in fact, we could transform this graph into a cumulative distribution function instead of density, and we would find that given this graph, given that it's nicely shifted to the right, and it's also a little bit more less variable, as Noam pointed out, we would find that at every percentage, we have more people in the control group who make less than that, at every level, we have more people in the control group earning less than that than in the treatment group. Which means that, well, it has to mean that the people in treatment group earn more. And not only that, but not every single person, but statistically, everybody in the treatment group does somewhat better. So we're saying the distribution in the treatment group stochastically dominates the distribution in the control group. That's, if you had to choose which society to live in without knowing, you would pick the treatment group, right? Because the chance that you are earning more is better in one place than the other. So that's what happens with this distribution. We can just look at them and say, yeah, we have more people earning less, and we have here more people earning more.